start learning data engineering from scratch? I have been seeing this question everywhere on Reddit, DMs, YouTube comments every single day. And honestly, there are so many roadmaps, so many courses, and so many opinions out there that most people don't just know where to begin. So today, I'm going to give you the most clearest roadmap you need to know. Now look, 2026 is actually a great time to get into data engineering. The demand is real, the salaries are solid, and the learning resources better than ever. But here's the problem. There's so much information out there that most people don't even know where to start. They open YouTube, see 47 different roadmaps, and just freeze. So in this video, I'm going to cut through all of that noise and walk you through exactly what data engineering is, what skills you need, and what has changed in 2026, and a clear step-by-step roadmap from absolute zero to getting hired. So let's quickly check out what we're going to cover in today's session. First, we will understand what a data engineer actually does. Next, we'll look at the basic skills you need to know to start. Then, we will explore the main tools used in data engineering. After that, we will understand how data pipelines work. We'll also see what kind of project you should build. And finally, we'll talk about how to become job ready. So before we begin, here's a quick quiz question for you. Which of these is the core programming language for data engineering? Your options are Java, R, Python, or C++. Drop your answers in the comment section below and let's see how many of you got it right. Now, before we get into the roadmap, let me quickly answer the 3 questions I get asked the most. Because if these doubts are sitting in your head, you won't focus on anything else. First one is, do I need to know coding? The answer is yes, but not scary kind. You don't need to build apps or websites. You just need enough coding to move, clean, and process data. Python, which is the main language here, is honestly one of the easiest languages to pick up. Basic logic is enough to get started. Second question is, do I need a math background? The answer is no. Basic math and logic is all you need, nothing like the heavy stuff in machine learning. If you can do simple percentage and understand basic logic, you are completely fine. Third question, I'm a fresher with zero experience. Is this even for me? The answer is 100% yes. With consistent focused study, even with 5 hours a week, you can be job ready in 8 to 12 months. No degree required, no prior experience required, just the right path and the discipline to follow it. Alright, I hope the doubts are cleared now. Now, before we get into the roadmap, let me quickly tell you what has changed in 2026, because the roadmap from 2 to 3 years ago is not the same anymore. Now, the core of data engineering hasn't changed. You still move data, clean it, transform it, store it. That's the same. But what companies expect from you, that has shifted in 3 big ways. The first change is AI is now the part of your daily workflow. In 2026, AI handles most of the syntax work. The bottleneck is no longer typing code. It's understanding whether the code is actually doing the right thing or not. Your role has shifted from being a code writer to being a code reviewer. Now that means understanding the logic behind the code is now more important than memorizing every line of syntax. The second change is real-time data is no longer advanced. Now, a few years ago, real-time streaming was considered a senior level topic, but not anymore. Companies have moved away from purely batch-based pipelines toward real-time streaming and lakehouse architectures. Tools like Apache Kafka, which used to be optional, are now expected even at the junior level. The third change is you now support AI systems, not just dashboards anymore. Now, this is the biggest shift ever. Earlier, data engineers built pipelines that fed dashboards and reports. But now, a huge part of your job is building pipelines that feed AI models. It's no longer enough to just move data efficiently. You need to make sure the data has enough context and quality for AI systems to actually use it. That changes what clean data even means. So now that you know what the landscape looks like, let's get into the actual roadmap. So I'll be explaining it to you in phases. But before you open a single course, stop. First, understand what a data engineer actually does day to day. Because so many people start learning and then realize 6 months in that this isn't what they wanted. So here it is, as simply as possible. Think of a city's water system. Someone has to lay the pipes, make sure the water flows correctly, clean it, filter it, and make sure it reaches the right place. A data engineer does the exact same thing. But with the data instead of water, you take raw, messy data from different sources like apps, databases, website, you clean it, transform it, organize it, and then you load it somewhere like a data warehouse or a data lake house so that analysts and AI systems can actually use it. But that whole process is called a data pipeline. And building those pipelines, that's your job. Now, you might be thinking, what's the difference between a data engineer, a data analyst, and a data scientist? Now, a data analyst reads the data and finds insights. A data scientist builds prediction models using that data. A data engineer makes sure that the data is there, clean, and ready for both of them. You are the foundation, nothing works without you. Now, once you understand this and genuinely feel excited about it, then you commit to this path. This one decision will save you years of wasted time. So now that you have understood this step, let's build your foundation, and this is where the real work starts. Phase 1, building your foundation. Now, this phase is not just about data engineering. It's about getting comfortable writing code and working with data so nothing feels scary later. Now, there are exactly 3 things to learn here, and one important rule before we start. The rule is 80% practice and 20% watching. Do not sit and binge watch tutorials. Every time you learn something new, open your laptop and try it by yourself. The struggle is where the learning actually happens. Also learn one skill at a time. Never two things together. Finish SQL before starting Python. Finish Python before starting Git. One thing at a time. First skill you should concentrate on is SQL. Now, SQL is the language you use to talk to data. It doesn't matter what data role you end up in, you will use SQL every single day. Start with the basics like selecting data, filtering it, joining multiple tables, then move to advanced like window functions, CTE, subqueries, views. Take your time there. Understand what each query is doing and why, not just how to write it. The second skill you should focus on is Python. This is your main programming language as a data engineer, and you have to actually get good at it. But here's the thing, you don't need to learn all of Python, just the parts that matter for data work. That means variables, data types, lists, dictionaries, loops, functions, reading and writing files like CSV, JSON, error handling, and connecting to databases and APIs. So that's your list. Keep it focused and don't go beyond it at this stage. Now, the next skill is Git and GitHub. Since your job is writing code, you need to know how to save it properly. Track changes, work with others. Git is the tool, GitHub is where the code lives online. Learn the basics, create a repository, commit your changes, push and pull, and honestly, you can learn this in a weekend. Don't overthink it. Now, once these 3 feel comfortable, you move to the phase 2. And this is where it starts to feel like a real data engineering. Phase 2 is learning the data engineering core. The goal here is not just to learn tools, it's to understand how data systems are built from start to finish. And I wanted to focus on concept more than tools. Understand the why before the how. The first step is to learn the theory first. Now, before touching any tool, spend time just reading and understanding the key concepts. Like, what is data pipeline? What is the difference between batch processing and stream processing? What is ETL versus ELT? Then you have what is data warehouse, data lake house, what is Apache Spark, and why does it exist? What is Apache Kafka? All of these terms. No coding is required here. Just read, watch, and understand. Get familiar with the language of data engineering so when you see these words in job descriptions, nothing feels foreign to you. The next step is to learn Databricks. Now, Databricks is a cloud-based platform where a huge number of companies do their data engineering work today. It sits right at the center of modern lakehouse architecture. You don't need to master it right away. Just understand what it is, what it's used for, and explore the basic interface. Like what is a notebook, what is a cluster. Get comfortable with the environment. Now, the next step is to learn Spark and PySpark. Now, Spark is the engine that processes massive amounts of data at a speed. PySpark is just Spark but written in Python. So, since you already know Python, you are halfway there. Learn what distributed processing means and why we need it. Learn how to read data, process it, and write it back. Keep it to the basics for now. The advanced stuff comes naturally as you work on real projects. Moving on to our fourth step, which is building one solid project. And this is where most beginners go wrong. They either build nothing or they start 5 projects and finish none. Build one, just one, but make it genuinely good. A great beginner-friendly project is building a data lakehouse from scratch. Take raw, messy data, run it through different stages, raw, clean, ready to use using Databricks, PySpark, Python, SQL together. Document the whole thing properly on GitHub. Write a clear README that explains what you have built, why you built it, and what the outcome was. This one solid project will do more for your job search than 10 certificates sitting on your LinkedIn. So now the skills are solid, projects are done. Now comes the part most people dread. Let's talk about actually getting hired. The phase 3 is getting hired, and let me be completely honest with you, the job market is tough right now, but it is actually doable. Now the most important thing here is your mindset. You will never feel 100% ready, but if you feel 60 or 70% ready, you are already ready enough to get started. Stop waiting for the perfect moment, it does not come. Now, let's talk about whether certifications are required or not. Well, the answer is yes. Get one, just one, pick the most relevant to what you have learned. Don't chase too many certifications at once because that wastes time, money, and energy. And here's the truth, a strong project will always carry more weight than a wall of certificates. Certificates show that you have studied, a project shows that you can actually do the job. Now, if you're still building your foundation, you can start the skills that matters the most. For data engineering, two of the biggest ones are SQL and Python. And if you want to strengthen your Python skills in a practical way, Simplilearn's Applied Data Science with Python course can be a great starting point for you. It covers important areas like data analysis, data wrangling, visualization, statistics, pandas, numpy, and it also gives you hands-on practice through Jupyter Notebook labs, assisted learning, and industry-based projects. So instead of just learning theory, you can also get a chance to work with real data sets and build practical confidence. So hurry up and enroll now. You can find the course link below. Next thing, let's talk about your resume. Keep it clean and honest. Don't list skills you only wish you knew. Recruiters spend around 10 seconds on a resume. Make those 10 seconds count. Simple layout, clear sections, and your project right at the top where it's easy to find. Next is your LinkedIn. The LinkedIn is not just a social media app. Don't treat it like one. Set a professional photo, write a simple, clear headline, list your skills, and feature your GitHub project so anyone who lands on your profile can see your work immediately. And as you learn, post small updates about your progress. It builds visibility without you needing to become a content creator. Next is your GitHub portfolio. And this is honestly your most powerful asset as a beginner. Clean code, good comments, a detailed README that explains the project like you're explaining it to someone who has never seen it. Think of your GitHub profile as your technical resume. It shows employers exactly how you can think and how you work. Next is applying for jobs. Apply wide, don't be picky at this stage. Your first job doesn't need to be your dream job. It needs to be a real job where you learn, grow, and build experience. Apply 100 times, 200 times if needed. Don't take rejections personally. Every interview is a learning experience. Figure out which questions you couldn't answer well, fix those gaps, go back and apply again. That's the process. Keep improving and keep repeating. Now, let's say all that hard work paid off, you got your first job, but here's the thing nobody tells you. The learning doesn't stop, it just changes shape. So let me quickly walk you through what the growth looks like once you are inside a company. So let's look at the growth journey now. Now, as a junior data engineer, your job is straightforward. Do the task given to you, make mistakes, learn from them, and ask lots of questions. Don't be shy about asking. Even the most senior engineers ask questions when they join a new project. And here's something really important. Don't only learn what your current company uses. If they are using outdated tools, you still need to keep your skills current. Keep one eye on the job and eye on where the market is moving. New skills to pick up at this stage like data security basics. Never put out passwords or access tokens inside your code. Never push secrets to a public GitHub. Start learning Apache Kafka for real-time streaming. Pick one cloud platform like Azure or AWS, depending on what your company uses, and start exploring AI engineering basics because companies are now expecting data engineers to support both analytic pipelines and even the AI pipelines. And here's one frequently asked question we saved for this moment, which is, will AI replace data engineers? The answer is no. It's making good data engineers more valuable. Your job is shifting from writing every line of code yourself to directing AI tools smartly and knowing whether the output is actually correct or not. So that judgment is a human skill. Now, as a senior data engineer, your role changes completely here. You stop executing tasks that others define and start owning complex problems yourself. You get the chance to review other people's code, mentor junior engineers, optimize systems for both speed and cost, design scalable data models, and think about the full system end to end. At this point, you will also get picky about where you work. You have enough experience to pick the right company, the right role, and the right culture. Now, as a data architect, this is the most senior technical part in data engineering. And the whole perspective changes here. You stop building and start designing. You are no longer thinking about how to build a pipeline. You are thinking about how the entire data platform should be structured in the very first place. You define blueprints that entire teams follow. You align technology decisions with business goals. You set the standards for data quality, governance, and architecture across the whole company. You are no longer writing code every day, you're making decisions that affect everything. Alright, that was the full picture from absolute beginner all the way to data architect. And now I know it sounds like a lot, but here's what I want you to take away from this video. You don't have to do all of this at once. Start with a phase, just SQL, Python, and Git. Everything else comes with time. Make sure you stay consistent, practice more than you consume, build real-world projects, and keep applying even when it feels hard. With just 5 focused hours a week, you can be job ready in under a year. That's a small investment for a career that can last decades. Now, if this video helped you, drop a comment below telling me where are you right now? Are you a complete beginner, already learning, or already in this field? And if you haven't subscribed yet, make sure to hit that notification button and subscribe to our YouTube channel for more such tech insights. Thank you and keep learning with Simplilearn.